All right, the next thing we're going to review is how to solve equations that involve logs or actually exponentials because they're related. They end up using each other when you solve these equations. All right, so there's two main ways we're going to solve the equation using the one-to-one property. This basically says this. I'll just write it here. If we have like a to the b equals a to the c, the only way these two exponentials can be equal is if just b equals c. We just take their exponents being equal. And the same thing works for logs. If you have two logs equal, then the insides have to be equal. The other one is the inverse property, when you can switch between a log equation and an exponential equation by just kind of flipping things in the right way. Most of this probably doesn't make sense when I say it in words, so let's do some examples. All right, solve 5 raised to the x equals 2. We want to solve for x, but we can't right now because it's in the exponent. But because this is an exponential equation, I can rewrite it as a logarithm equation. Log, base 5, because that's the base of the exponential. All right, the answer for the exponential goes inside the log. The exponent of the exponential goes over here. So now I know x is log base 5 of 2. All right, so this is the idea of using the inverse property. You can switch from exponentials to logs. And in this case, it just happens that once you do that, you're basically done. You get your answer for x. In this example, this is a natural log problem. Natural log of 1 over x equals 4. Again, we can't just solve it straight away because this x is inside of our natural log. But again, what we can do is rewrite this as an exponential equation. So natural log is log base e. So if I switch this to an exponential equation, it's going to be e raised to the 4th equals 1 over x. Again, the thing over here switches into the exponent. The thing over here switches to the other side. Now I can solve for x. I can multiply both sides by x and then divide. And I get x equals 1 over e to the 4th. Generally, you would leave it like that, but you could also technically write it like this as well, e to the negative 4th, because that's how negative exponents work. All right, so in these last two examples, you can see how we can just kind of quickly rewrite our expression that involves an exponential or a log using the inverse property, and then kind of solve a simpler equation after that. Technically for exponentials, you can do that most of the time, but another thing you can do with exponentials is use this one-to-one property. So it might not be obvious how you use this here, but I can rewrite a lot of these expressions. So 8, I can rewrite as 2 cubed. And 4, I can rewrite as 2 squared, and that's still raised to the x. So what I'm doing here is I want everything to be the same base. So now everything is base 2. My exponent rules on the left say if I multiply these, I add them. My exponent rules on the right say if I have this double exponent, I multiply them. And then the nice thing with exponentials, if we have these two exponentials with the same base, so it's important these are both base 2. But now I can just take the exponents and say those are equal. So this equation is much simpler. There's no more exponentials. I just subtract the x, and I get 3. This is another way you can solve exponential equations. Generally, in calculus problems, you don't use this one as much, but it is another option. And if you see two exponentials that are similar, maybe you can rewrite them and use this one-to-one property instead of involving logs. With our logarithms, we might have to do some extra simplifying first. So with this natural log, you can't do the inverse property or anything until you have just a single log. So what I'm going to have to do first here is do some of that simplifying we talked about in the rules video. And there's actually two ways. I didn't realize this. There's actually two ways to solve this problem. So let's do it in a way we haven't done yet. What I can do now is add this right-hand log to the other side. So I can get an equation that looks like this. And I'm also going to do this exponent property. X squared cubed is going to be x to the 6th. I didn't think about solving it this way, but now as I'm recording the video, I see I can just add this log to the other side. And now this is just like the last example. We have a single log on each side. So we can actually get rid of the logs using this, what's technically called the one-to-one property, and write it like that. Just like we got rid of the exponentials previously. To solve this formally, you would subtract this 2x to the other side, Right, factor out an x, and then split this up into two different equations. So one is going to be 0 equals x. The other is x to the fifth minus 2 equals 0. I add 2 and take the fifth root of both sides. One thing that you have to do with log equations, you don't have to do with exponential equations. You have to check to make sure the answers you get at the end make sense. This one is going to end up making sense. I can plug in the fifth root of 2 into either one of those things. But 0, I remember when we were talking about the basic definition of logs, you can't plug in 0 or negatives into your logarithm. So if I tried to plug in 0, I would get the natural log of 0 there, and that's bad. So I had to kind of just cross that answer out. It doesn't actually make sense, and I just get this one answer. There's a lot of information in one video and a lot of examples. But you can kind of see the basic ways that you can solve log equations, because when you're doing the AP exam or examples, you might have to solve an equation for an intercept or something like that, and these are the kind of basic methods for that.